Okay, welcome to the ET197 How to AC Challenge Troubleshooting Simple Circuits. Okay, we're at our AC Circuits Challenge, and we're going to go straight to Troubleshooting Simple Circuits 1. Okay, let's begin. Well, no, let's not begin. Let's hint. Alrighty, so this is an AC circuit. It operates different than a DC circuit. So let's go through. A blown fuse is going to have a zero current. All right. And our voltage at the bottom of the fuse is going to measure 0 volts. All right. If we have a capacitor that's open, we're going to get the full voltage on both sides of this. C1 shorting, we're going to get a non-zero reading and both sides of this terminal. Okay, one we're going to have the applied voltage, the other side we're going to have a ground. Okay, if it's shorted, we're going to be the same on both sides. Not good. If our resistor is open, we're going to get a voltage on top, which should be the applied voltage, and we should get a ground on the bottom. R1 shorted, we're going to get a non-zero reading. They're going to be current through there, and it'll be wrong, and we're going to get the same voltage. Anytime that we have a cut, you're going to get the same voltage. I mean a short. Whenever you get a short, you're going to get the same voltage on both sides. So if it's open, we're going to get zero current. If it's shorted, we're going to get a non-zero, and the bottom's going to be ground, and the top should be applied voltage. And if we have a trace open, we're going to measure on one side. And if there are no faults, our capacitor should be a higher voltage than our applied voltage. Okay, and that's because of the way the AC circuits work. So resistors are fixed, so their AC and DC will be the same. Capacitors under AC will be different, and inductors will be different. And that's because of the complex way that AC circuits work. Okay, enough talk. Let's troubleshoot. Okay, zero current means that we have an open. Okay, so let's divide and conquer. 24. Okay. And let's go down here. We got 24. And here we have 24. And here we have ground. So that means probably our L1, which L's are inductors, is open. Good. Divide and conquer. 24. 24. That means we have an open. No current and voltage. Well, let's keep chasing it out. 24. Ground. 24. Well, let's see here. That means our inductor's open again. Alright, no current, full voltage. We have an open somewhere. Oops. Oops. Okay, that means our resistor's open. We have voltage on one side and ground or on the other side. So let's say R1 is open. Good. Divide and conquer. 7. That is good. That is not good, because here we have 18 and our capacitor. Okay. Well, in this case our voltage is lower. That's probably okay. Let's go 9. Oh, we have a ground here. Not good. How about here? Not good. I'm going to say our inductor is shorted. Good. We have current. We have a higher voltage. That means this guy is working good. Let's go down here. We have no voltage drop across our resistor. Okay, let's go over here. Okay, I'm going to say our resistor, let's see. let's say our resistor is shorted. We shouldn't be getting the same voltage on both sides. Good. Divide and conquer. No current. We have an open. 24. Okay, let's see what we have a problem. That's ground. That's ground. That's ground. That's ground. And that's a full voltage. So I'm going to say trace 2 is open. We have voltage on one side and ground on the other. So I'm going to say trace 2 is open. Good. Divide and conquer. 0. No current. Okay. No voltage. No voltage. Voltage. So our trace 1. We have voltage on one side, nothing on the other. That should be our trace 1 open. Good. Alright, again, no current, no voltage. We have voltage, no voltage. It's open. C1 is open. Again, no current, same voltage. We have an issue. We just need to figure out what it is. Do we have a voltage drop across our... Nope. 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 So it looks to me like our trace 4 is open. We have current. Oh, we have the same voltage on both sides. That's a problem. Okay, let's see. Do we get a voltage drop across the resistor? Yes. So I'm going to assume our inductor is okay. So it looks to me, same voltage across, looks like our capacitor is shorted. Good. And we finished. Oh boy. And I'll show you again here. Just put your name in there. And we're going to skip disk storage. Here, that's okay. And we're going to print this to our cute PDF and upload it into our canvas.